So hi, everybody. Greetings from Sydney, Australia. My name is Matt Ray. I'm Chef's customer architect and regional manager for Asia Pacific Japan. It's my pleasure to present today here at HashiTalks. Hopefully you've enjoyed some of the other sessions. I may make a reference to one or two of them as we go. But today, I'm going to be talking about Chef's tools and Terraform and how they work together. There we go. So first off, Chef loves Terraform. I'm here to tell you that the folks over at Chef, we're big fans. Actually, we're big fans of all of HashiCorp's tools, but today I'm going to keep it just to Terraform. We work with a lot of those other tools, but today the topic du jour seems to be Terraform for not just my talk, but a lot of these. But so you may be asking yourself, it's great that Chef loves Terraform, but why are you folks such big fans of it? What's so great about it? Well, first off, we're very heavy users of it across our organization. We use Terraform to deploy some of our multi-node high availability clusters, both for our customers and for ourselves. We run quite a few hosted services, and almost all of them are managed with Terraform. Our development team uses Terraform extensively as we test different topologies and configurations of our applications, and our customer-facing teams use it extensively with our customers. So we see a lot of that out in the field. We see the provisioning and configuring of infrastructure. It's essential to how Chef manages servers with configuration management. But not only do we use it, our users and our customers use it too, right? And there are extensive integrations across Chef's projects and Terraform, and with a lot of the other projects as well. And because there's so many complementary use cases and our companies are kind of on fairly friendly terms, we do some webinars and other events with the Hashi folks, and so hopefully we'll see them and you at ChefConf in June. But some of you might not know who Chef is. So for those of you who don't know about Chef, we are an open source automation company. Our mission is to help companies become to help them use Chef to become fast, efficient, and innovative software-driven organizations. You've heard the saying that software is eating the world. Well, we like to help companies make that transition to becoming software companies. And part of that is, we're really big fans of infrastructure as code. Obviously, we're active in the DevOps scene, and and we've been around for more than 10 years. So we've kind of grown up with a lot of this stuff as well. And so Chef the company is named after Chef the software, which we call Chef Infra to help distinguish them. So if we say Chef Infra, we're usually talking about the software. And Chef Infra is open source infrastructure automation. It's configuration management that helps provision, harden, and maintain the configuration of your servers, no matter where they are. So cloud instances, VMs, bare metal, it's kind of all the same to us. So, then of course, some people might not know it. Oh, one slide too fast. Some people might not know what Terraform is, probably not the people on this call, but I shouldn't have to tell you that. But for those of you who don't know, Terraform is a very powerful and flexible tool for provisioning and managing infrastructure. So it's really good for all the pieces of what it takes to deploy infrastructure, whether it's in the cloud or on virtual machines. There's some bare metal support as well, but it kind of is the glue for everything outside the server. And we'll talk about what that means in a bit. So there are a lot of tools out there, a lot of great ones. And but if any of you work with carpentry or any other tools, they're 4 different hammers, and everyone might have an hammer's the best tool. So what we're trying to do is to pull the best tools together in just a few solutions that are proven to help get that elite performance that the high-performing organizations have. A stack that all fits together. That's what we try to provide. And so to that end, what we do at Chef is we focus on 3 areas. Most folks know us for infrastructure as code, and that's the Chef Infra project. But if you're going to manage infrastructure or anything really, you're going to want to run it securely in a compliant fashion. And so our security and compliance as code project is called Chef InSpec. Hopefully you've heard of that, and I'll talk about that a bit. And we've also figured that managing applications it's not the same as managing infrastructure or managing servers. So we developed our Chef Habitat platform to help manage the life cycle of applications, no matter where they run. And I'll talk some more about each of these. But what we do is provide these all together in a enterprise automation stack for applications, infrastructure, and security. All of it manages code. So everything comes back to code, just like you're going to do with Terraform. We do it across compliance and infrastructure and applications. And the reason, of course, is you can manage the versions. It evolves easily. You can test it. You can see the diffs as you go, check it for accuracy and safety. And code is fairly unambiguous. It does what you expect. And you can use well-established software development patterns to manage that code, something that hopefully we're all familiar with. So Chef Infra, it's infrastructure as code. That's where we got our start. Linux, Windows, Unixes, no matter what operating system you have, VMs, cloud instances, bare metal, Chef manages the configuration of that. Everything above the operating system. As soon as that box is deployed, we're going to help set up what's running on it. And there's some examples there on the right of what Chef code looks like. It's Ruby. We've got a tremendously large open source ecosystem of shared cookbooks for managing everything under the sun. We've been doing configuration management a long time. We manage customers at every scale, whether they're running 5 to 10 boxes in a small home lab like myself, or more than hundreds of thousands like some of our other customers. And we have some very large customers. So and so when it comes to Terraform, if you read Terraform's documentation, they have fairly strong recommendations against using provisioners. So provisioners are kind of taking that step of configuring the machine after it's been installed by Terraform. And there are some good reasons for not messing with machines. The recommended pattern from HashiCorp is to use Packer. To build an AMI or VMDK or Docker instance, whatever it may be, that you put your configuration in and you turn on the box and it just runs without needing any additional configuration. Unfortunately, you don't always have that option. Not everyone builds their images in advance. Perhaps they have too many variations of their applications. The machines are long-lived. They expect to deploy into dynamic environments that can't be pre-configured easily. There are definitely reasons to use provisioners, and I'm pretty sure that a lot of the Chef Terraform users are using these together. So the Terraform Chef Provisioner is if you want your resource to be managed with Chef. It's going to use the client server model of Chef. So you'll put in all the usual bootstrap options. You can put in your versions, your your secrets, proxies, all that fun stuff. And then once the instance is stood up, it's going to connect to it via SSH or WinRM for Windows. If you prefer to use Chef Solo or Chef Zero, you could easily use the local exec or remote exec provisioner to kick off a script. Definitely that's a perfectly valid use case if you're not using a Chef server. We're happy to help you off with that. You can assign attributes and policies to your machine. If you're still using roles and environments, you can of course use those. The documentation is quite thorough. We know that there are a lot of users. It's pretty well battle tested. We use it quite a bit ourselves and help our customers use it as well. All your cookbooks and resources, they'll get downloaded from your Chef server, so you don't have to bundle everything in advance and put it onto your machine. There's the link to the documentation. It's pretty straightforward. Especially if you're coming from the Chef side of things. But I've got I've got a quick demo that I was going to do it live, but I'm on hotel Wi-Fi, so I went ahead and recorded it. I'm cheating. But all the code for today's demos are in that repository. I've got a little README that has some documentation about, my script that I use for setting things up. But this is what the Chef Provisioner looks like in the demo. I've taken the AWS provider 2-tier example. So if you go into that provider, the AWS provider, there's an example of standing up an ELB with a single web application. That's the demo I'm using. I've just modified it to use Chef. The source, again, it's all there. So I've modified the main TF that comes in that demo. So it's just going to deploy a simple web page. And in the repository, I've got a variables.tf that defines what all these variables are. I've added, the Chef server URL, the location of your user key, your username, and then what you want your node name. And I'm using policy files, so policy groups and policy names. You could easily change this to use, environments or roles or attributes if you want to. It's pretty straightforward. So I'm going to go ahead and kick off a quick recorded demo I did of just the Chef Provisioner in action. So first off, we're going to, I'm using Terraform. I recorded this last night, and a new version of Terraform came out while I was recording it. So I'm using 12.20, 12.21 apparently came out yesterday. So we're going to stand up our AWS instance. You can see the Chef Provisioner kicking off there. I'm using 15.8.23 of the Chef client. It starts up, it downloads it, installs it, accepts the license, starts off the Chef run, installs Apache, and it's pretty fast. This is sped up a little bit, but I spit out the ELB address and go to the website after a minute. I sped that up too. So, it takes about a minute for the ELB to start routing traffic, but that's what the web page does. And, this is a trivial example. The remote exec or local exec would have been fine for this, but you're probably going to use Chef when you have a more complicated use case. If you're configuring larger applications, not stateless web apps, you'll probably, this day and age, you'll use something like Docker or even Kubernetes for that. But if you have, a stateful large application or multiple machines that need to, interact with each other, that's where Chef is probably going to shine, especially in an enterprise environment where, you've got all sorts of settings coming in from who knows what is happening in your enterprise. I see a lot of great things out there. So that's the Chef Provisioner. It's pretty straightforward. There's also a Chef Provider. A provider is a little bit different from the provisioner. The provider exposes resources on external systems for management by Terraform. Their examples, of course, are AWS or some of the databases have providers. Well, the Chef Provider allows you to manage resources on the Chef server. It's been around for quite a while. A lot of interactions between Chef and HashiCorp in the early days of Terraform, and this one was fairly early in the development. It manages environments, roles, data bags, and of course nodes. There are some gaps in the coverage, but most people, I guess, aren't having too many issues with that. Policy files are a fairly new development that we definitely encourage people to use. And there are other ways to manage these features. But, the documentation is, again, fairly straightforward. You need a validated user and a credential to get to your Chef server URL. And then, if you have the permissions to do it, you can manipulate objects on the Chef server. So that's the Chef Provider. It's I'm not gonna really demo that. Just talking about it because there's a lot of ground to cover, and we only have about 30 minutes. So Chef Habitat is a fairly new project from Chef. It's about 3.5 years old. And what Habitat does is it comes out of our experiences running running with Docker. In the early days, a lot of folks thought that they would put Chef inside of Docker, and that's not really the right mindset, right? You don't want to have a configuration management agent inside a container trying to change things. You want to build it properly the first time, like you will with Packer, and push that out. Well, what Habitat does is it's application automation. We want to take any application and build it in a repeatable fashion with explicit dependency declarations in an automated fashion, and deploy that into any sort of infrastructure, whether it's bare metal, VMs, cloud, containers, Kubernetes, without rebuilding the application. So we want to isolate our application from the operating system or the runtime environment. We want immutable build artifacts. And the goal here is, to on commit, your application gets built and packaged. It gets put into a release channel, continuous delivery release channel for whatever your workflow is, and then it gets picked up and deployed into the right environments. You might have a QA environment, or blue-green environments, stable, unstable, whatever it is. Habitat supports the concept of release channels, and this works across Linux and Windows for building and packaging and managing applications on any platform, really. And so that's kind of what Habitat's about. And there's a lot to unpack there. You have a plan, which is how your application is built and how it runs. And that plan for Linux, it's written in Bash. So Habitat doesn't have anything to do with Chef. If you're writing for Windows, your plan is going to be in PowerShell, because that's how you build and manage, or it's how you build things and manage them in Windows. And that's going to produce an artifact that is completely reproducible, as a manifest, tells you exactly which versions of everything that went into both the building and the runtime of that application, produces an artifact, puts that in a depot. From that depot, a Habitat supervisor will deploy that application later into the environment of your choosing. And without ever having to repackage or rebuild it, because you've switched from bare metal to Docker, for example. So this is really different from traditional configuration management, where traditional configuration management, you're starting at the operating system. You have an OS that you have to harden and patch, and then bring in system libraries, and then bring in the application libraries to support your application, your JDK or what have you. And then the application sits on top of this pyramid of moving dependencies. And that's kind of brittle for applications. And so Habitat kind of flips that model and says, well, what if we can isolate the application to just its runtime dependencies, strictly control those, and isolate our application away from the OS as much as we can? And that's how a Habitat package works. It doesn't, it's not going to produce an artifact that has a lot of dependencies from the OS, which means that if your application runs on Red Hat 6, it'll run on 7, run on 8, run on Slackware, run on Gentoo, run on Debian. It doesn't really matter, as long as you have a stable kernel interface to run against. Windows, very similar, not as isolated as Linux, but very, very. It makes it possible to run old applications on new OSs and new applications on old OSs. And so that's the promise of Habitat. And when you have your application packaged in Habitat, you can use the builder. We have a SaaS version. You can run it on premises. And what the builder does is it takes the plan for your application and package, and you pointed at your source control, GitHub or GitLab or whatever you may be using, and on commit, it will rebuild your application and produce new artifacts and publish them to an unstable channel, or you can name your own channels, and then you can take that exact artifact and promote it when you are sufficiently happy in how it is performing in whatever environments you've tested it. And so you don't recompile to run in different environments, you just promote that that package. And so that's kind of the killer feature of the builder, is isolating your application away from the OS, and then publishing new versions of it and updates to it as you go. And so there's a habitat provisioner from that works for Terraform, and this will kind of has two levels to it. The first is it's going to install and load the habitat supervisor on the machines of your choice. And that will, the supervisor will get deployed. It's just a small Rust binary. And then for that supervisor, you can configure what channels it's subscribing to, whether it can upgrade itself, which other supervisors it's going to talk to and share information with. So they form a gossip ring. And then what services you would like that supervisor to manage. And so that service, you could say like, oh, I want to run Nginx and I want to subscribe to the green channel of application Y, and serve up, that application anytime a new build comes out. I'll take mine down and replace it with this one. You can have topologies. So you can say, well, we're running in a multi-node setup. We're going to do one at a time upgrades, or rolling upgrades, or all at once, whatever upgrade strategy you would like your application to deploy, so it'll halt on failure, so you don't take down your entire cluster, for example. And you can define the bindings of that application. So if you're running a database tier and a middleware tier and a load balancer tier, you could bind them to each other. So Habitat handles some of that plumbing between those services. As you move into Kubernetes, obviously you'll offload that into, let it handle those sorts of things, but not everybody has service discovery. We work with Console as well, but that's Habitat. Right now, the Chef Habitat Provisioner only works with Linux. The Windows support has not been implemented yet, but other than that, it's fairly fully featured. We definitely have, we use it extensively ourselves, and we've got customers using it today. So that's the Habitat Provisioner. Not really going to demo that either. Just don't have all the time in the world. I'm looking at my time, I need to hurry up a little bit. So Chef InSpec is what we call compliance as code. InSpec allows you to take the PDFs and Word docs and Excel spreadsheets that everyone is using for compliance and turn those into software checks. And so when they're software checks, you can bring them into your CI/CD pipelines and quickly find what's going on with your infrastructure. Again, InSpec doesn't require Chef, it doesn't require Habitat, they're all independent of each other. But InSpec allows you to check resources on machines, lets you talk to databases, lets you talk to APIs, allows you to introspect your cloud infrastructure as well. So there are hundreds of resources built in. InSpec's proven quite popular, not just with Chef, but other configuration management tools and compliance folks as well. And there's a small example of a rule down there on the bottom right, where you have a control for Windows, and just ensuring that NTLM authentication is enabled, looking at registry keys. I mean, pretty much if you can manage it via configuration management, you can check it with InSpec. And it's remote or local, so it doesn't require an agent unless you want it. InSpec does work against cloud APIs. The Center for Internet Security has a set of benchmarks for testing the compliance of all the different cloud platforms. Chef was the first vendor certified across all three of the major cloud platforms. And this just lets you write policies for checking your cloud configuration, looking that VMs are set up properly, security groups are in the right places, block storage, S3 buckets, access management, logs, all that fun stuff. InSpec's gonna allow you to check it. So Kitchen-Terraform is one of the tools in the Chef ecosystem. Actually, Annie Hedgepeth gave a talk earlier at HashiTalks, a session a few hours ago. If you didn't catch it, please go catch the YouTube session. She had a very nice blog post about it. We're working on a talk for ChefConf later. But Test Kitchen is a testing framework that allows you to stand up VMs, whether it's with Vagrant, again, working well with Hashi products, working with Vagrant, or directly against cloud APIs or VMware APIs. And in this case, it works with Terraform. And then Terraform will pass through to its provisioners, stand up, or providers, stand up the machines for you, multiple machines, and then it'll use InSpec as the verifier to actually run the checks against the infrastructure you just stood up. And so the Kitchen-Terraform driver is listed there in code. Annie's talk is much more in depth, so please go check that, because I'm not going to cover that today. And then the last integration that I'm going to talk about today is something actually I wrote. InSpec-Iggy is the name of the project. InSpec-Generate, IG, Iggy, that's where it got the name from. It's an InSpec plugin for generating compliance controls from Terraform. What this means is it actually takes the TF state after you have deployed your Terraform infrastructure, and then it's going to map that into InSpec resources. And so this is completely dynamic. So as you stand up new infrastructure with Terraform, you can automatically generate coverage for it. It does work with CloudFormation, but we're here to talk about Terraform. There's also InSpec-Terraform negative, and what negative does is it takes your Terraform TF state file and then goes to your VPC and sees if there's anything that was not managed by Terraform. So maybe not only are we checking for drift, but we can check to see if there's stuff in your account that's not managed by Terraform. And so if everything you have is managed by Terraform and you run this and you find a few VMs running Bitcoin mining, well, that's what, hopefully that's what Iggy is for, to help you out with. So I've got a quick demo of that, and then we'll kind of wrap things up and get to the code, or get to the questions if you have any. So first off, I'm running InSpec-Terraform generate. I've got some deprecations to clean up there, but that's going to generate an InSpec profile. We'll go take a quick look at that. The InSpec YAML is kind of the direct, the metadata of that. There's the title of the one I just generated. It's running against the InSpec AWS plugin. I'm testing AWS. And then the controls that it generated are all dynamic. So the chef provisioner that I ran earlier spit out a TF state file, and then I ran InSpec-Iggy to generate coverage of it. I've got my ELBs, my AWS EC2 instance, the instance ID is there, the availability zone. So if any of these things change, I'll get notifications when I run this audit. It'll check the VPC, make sure that everything's in the right place, and then I can run this directly against the AWS API. And so InSpec-Exec, that platform, and I've got looks like about 26, 27 checks that were just generated automatically, checking the ELB and the AIM, the EC2 instance. Not a whole lot of stuff. It's a small example, but I can also send this directly to Chef Automate, which is our reporting and visualization project. So take my InSpec configuration file with a token and the URL of my Automate server, and I can just run that same test and pipe that output directly into Automate. And this allows me to run automated checks against my infrastructure periodically. So this is Automate. I can click on the compliance tab. I'll get a node called InSpec-Iggy. And then here I can see the output of the InSpec coverage for my Terraform that I just created. If I go to past controls, I can see my various audits expanded. I can see the source code that I just generated, the results. It's all there. If I wanted to see the history of the various scans, I get this over time. Automate will tie into your reporting and Splunk and ServiceNow and whatever you have to help you track these things and raise tickets if something happens. When I'm done, Terraform destroy this thing, and then I can go and run the InSpec checks against it again just to verify, hey, it's actually gone, and I blew it up. So I sped this up a little because it takes a few seconds to delete. So then I run my inspec exec against it again, just directly to the CLI so I can see my output. And most everything's failing. I actually ran it fast enough to catch that EC2 instance before it was totally gone. So it still existed. I'm sure it was shutting down and terminating. If I send that into automate, it complains that the ELB is already gone, but that's to be expected. I hit refresh. I have a new report. I can filter on my profile for my HashiTalks demo, and I can click on my failed node and see there's all my failures. And that's what you want, right? You just want nice reporting and visualization of things as they fail. So that is that's the demo. I had to compress it quite a bit to fit in the time, but I think that's, yeah. Go to my next slide. There we go. So just a quick recap. Chef Infra, Chef Habitat, Chef Inspec, Chef Automate. Those are our open source projects. My GitHub is there. Things I talked about, the integrations are all there. Just a quick pitch for ChefConf. It's coming. The CFP has ended. I know there's some Terraform, and I think last year we had a console and a Nomad talk. I hope there are some Vault talks as well. So there's going to be a lot of overlapping content, I'm sure. Hopefully I'll see you either in Seattle or London. I'll be talking about Terraform. And so thanks, everyone. If you have any questions, that is, you can hit me up at HashiTalks@mattray.dev. I'm on IRC, GitHub, Slack, Twitter, all those things. Software Defined Talk is my podcast, and mattray.dev is my